Okay. Well, we continue with more examples and more results and more properties of functions, real functions. Well, the exercises which I give, I hope you are taking up. Relations and functions. The equality of two functions. Again, this is a revisional topic. Two functions f and g are equal if they have same domain. Both f and g must have same domain, and fx equal to gx for all x in the domain. And we write f equal to g. Operation on real functions, that again we know, we studied it, addition of two functions, f from a to r and g from b to r, and a intersection b I call x, then f plus g has a domain x, that is a intersection b. So f plus g is a function from a intersection b to r, that is x to r. X to r defined as f plus g of x is fx plus gx for all x in x. So domain of f plus g is the intersection of the domain. Similarly, subtraction, same definition. The domain of f minus g is also a intersection b, f minus g of x is fx minus gx. Constant multiple of a function. F is a function from a to r. K is any real number, then k also is from a to r. Kf of x will be k into fx, where k is a real number. Product of two functions, same thing. F and g are two functions. The domain of fg is also a intersection b. Fg of x is fx into gx. This is a revisional point. But while we take the question, we only take care that gx cannot be 0, or those x where gx equal to 0 is removed from a intersection b. So f by g is defined from x to r, where x is a intersection b minus 0 sub gx. F by g of x is fx by gx. Remember that f by g is defined only if gx is not 0. Be careful about that. F by g is defined only when gx is not. So fx equal to ax minus b upon cx minus b. What will be the domain? Ax minus b and cx minus d are two polynomials. Both of them have domain R itself. Cx minus d is 0 when x equal to b by c. So the domain will be R minus d by c. Can you tell the range of this function? You studied in 11, range of this function. Domain will be R minus d by c, R minus d by c, and range will be R minus a by c. You have done it in 11, so I don't repeat it, but you can remember it. Fx equal to ax minus b upon gx minus d. Okay, fx equal to ax minus b upon cx minus d. Domain will be R minus d by c, and range will be R minus a by c. R minus a by c. Can you take this example? What will be the domain? What will be the range? Can anyone tell the domain? Domain will be R minus, hello, domain.
Yes, sir.
Now what will be the domain of this function? Nothing to worry, denominator should not be 0. Denominator should not be 3x plus 7 should not be 0. X should not be minus 7 by 3. Are you not getting? Denominator should not be 0. 3x plus 7 should not be 0. Or x cannot be equal to minus 7 by 3. And range is R minus 5 by 3. You can remember this as formula, but be careful about it. I have taken fx equal to ax minus b upon cx minus b. B has no role. Remember, A, C, and D are playing the role. No matter whatever is B, it is not affected. So if it is Cx minus D, Cx minus D equal to 0 when x equal to D by C, R minus D by C. And here R minus A by C range. You may keep it as a formula, no problem. You are done it. So this will be R minus 7 by 3 is the domain, R minus 5 by 3 is the range. Now I have a question.
How we got the range?
Hello?
Sir, how we got the range?
Well, if you want the range, you keep y equal to fx, and find the value of x in terms of y. Try to work out. You put y equal to fx. That is how we find the range. What do you mean by range? Range is set of y, where y equal to fx. And then from there you get x in terms of y, and you will see that y cannot be equal to 5 by 3. Start working out, and you just tell me tomorrow. You write fx equal to y, and you get x in terms of y. And then you will see y cannot be equal to 5 by 3. That is, range cannot be 5 by 3.
Okay.
Well, yes. You can say, I have a question here. This is a very common question which is asked in board. F from R minus 6 by 7. Why R minus 6 by 7? 6 by 7 is not in the domain. R minus 6 by 7. 2. R minus 4 by 7. Why? The range cannot have R 4 by 7. That's why I taken R minus 4 by 7. Is a bijection. I will show it is 1-to-1 and 1-to. I will show this F is 1-to-1 and 1-to. Very common question, but procedure you see very carefully. Very simple. To show F is 1-to-1. What is a 1-to-1 function? Can you recall it? We need to show that fx1 equal to fx2 implies 1-to-1 function means distinct elements have distinct image, or fx1 and fx2 are equal, then x1 must be equal to x2. So I start with fx1 equal to fx2. I have to ultimately show this implies x1 equal to x2. Well, I have taken x1, x2 in the domain. fx1 equal to fx2 implies. Well, what is fx? Fx equal to 4x minus 1 by 7x minus 6. So fx1 is 4x1 minus 1 by 7x minus 6. fx1 equal to fx2. Just go on simplify, cross multiply. 4x1 minus 1 into 7x2 minus 6 equal to 4x2 minus 1 into 7x2 minus 6. On simplifying, right? 21x1, 28x1, x2 cancels. 6 cancels. After cancelling that, you are getting, taken that x1 here and 7x2 there, you get minus 24x1 plus 7x1 equal to minus 24x2 plus 7. Oh, that implies minus 17x1 equal to minus 17x2. Or we are done with that. It implies x1 equal to x2. That means ultimately we are shown fx1 equal to fx2 implies x1 equal to x2, so that f is 1. Very clear? To show that the function is 1-to-1. fx1 equal to fx2 implies x1 equal to x2 for all x1, x2 in the DOM. Well, now we have to show that f is onto. What is an onto function? For all y in the codomain. Here remember the codomain is R minus 4 by 7. For all y in the codomain, we have to produce an x. We need to produce an x in the domain so that fx equal to y. Are you clear about the range? I mean, the onto function. F from A to B is onto. If for all y in B, we get x in A so that x equal to y. So I have taken up a y in the codomain B, that is R minus 4 by 7. I must get an x in the domain so that what I do is that I suppose fx equal to y, and see what happens. Suppose fx equal to y. I do not know whether there is an x, but I'm just daring to propose fx equal to y. That means 4x minus 1 by 7x minus 6. That is your fx. That is considered y. Well, cross multiplying 4x minus 1 equal to y into 7x minus 6, or 4x minus 7xy. 7xy is taken here equal to minus 1 taken there, 1 minus 6y. Or from there I take x into 4 minus 7y equal to 1 minus 6y. Or what is x? 1 minus 6y upon 4 minus 7y, or as good as 6y minus 1 upon 7y minus 1. When you start for finding the range of this function, this is the same step. You get this. So y cannot be equal to 4 by 7. That is what we mean by. That is how we get the range. So 6y minus 1 by 4y minus 7. Well, but this x cannot be equal to 6 by 7 because the range of this function cannot contain 6 by 7. So x cannot be 6 by 7. And we know this function has a domain 4 by 7. That is y belongs to r minus except 4 by 7. Y belongs to r minus 4 by 7. And this function has a range r minus 6 by 7. That is, this x belongs to r minus 6 by 7. And what is fx? More important. I have to show here fx equal to y. Even though I started with this, but after a long step, I must show that fx equal to y. What is fx? F of, what is our x? 6y minus 1 by 7y minus 4. Look at very carefully. I want fx. What is our fx? You know, fx is 4x minus 1 by 7x minus 6. That is my fx. But now I am changing x to some other number. F of this, that was my x there. That was my x there. X was 6y minus 1 by 7y minus 4. So I want f of 6y minus 1 by 7y minus 4. That is, fx is 4x minus 1 by 7x minus 4. Take this step very carefully. F of this will be 4 into this. 4 into x. What is x? This. Minus 1 by 7 into x minus 6. 4x minus 1 by 7x minus 6. But instead of x, I replace this. Instead of x here, I replace with this term, 6y minus 1 by 7y. Fx is 4x minus 1 by 7x minus 6. F of this quantity is 4 into this quantity minus 1 upon 7 into the same quantity minus 6. This point you take care very carefully. You need to master this. You need to keep this in your mind. Okay, further simplification is simple. I take the LCM, the denominator cancels on multiplying, and simplifying. What I'm getting is y. Just simple simplification. So what I got is that for all y in the codomain, we got an x in the domain so that fx equal to y. For all y in the codomain, this is codomain, we get x in the domain so that fx equal to y. For all y in the codomain, this is codomain and this is a domain. For all y in the codomain, we got x in the domain so that fx equal to y and hence f is 1 to 2. Well, now f is 1 to 1 and on to, hence an injective and subjective, and hence it is a bijection. So fx, you have to show it is a bijection. We show it is 1 to 1 and on to. 1 to 1 means fx1 equal to fx2 implies x1 equal to x2. On to. For on to, what do we do? For all y in the codomain, we get x in the domain so that fx is y. Once it is 1 to 1 and on to, we have a bijection. Let me pick up one more question, which the domain is simple one. The range is a little out of box, but not, I'm not talking anything beyond the syllabus. Normally it is, especially when you have to hear many objective questions, it can take care of it. Domain is very simple. How to find the domain? Both numerator and denominator are polynomials, and you know polynomials, the domain R itself, but the denominator should not be 0. When is the denominator 0? We could factorize it as x minus 2 into x minus 3. So domain, the fx is defined when the denominator is non-zero. That is, x is not equal to 2 and x is not 3. So the domain is every real number except 2 and 3. It's a very common question. It is a 1 mark filling blanks question or multiple choice question. Okay, now for the range. Be careful about range. How to find the range? I want set of y value. What is range? Set of y value where y equal to fx. I take y equal to fx and I want the set of y value. Okay? Y equal to fx. Careful about this. Y equal to fx. Cross multiply. Y into x squared minus 5x plus 6 equal to x. cross multiplied, y into x squared minus 5x plus 6 equal to x. Be very careful this time. Or open the bracket, yx squared minus 5xy plus 6y equal to x. I avoided that. That's all terms taken left side. Yx squared minus y 5x, right? Minus x, that I combined, minus of 5y plus 1 into x plus 6y equal to 0. Well, what does that mean? Considering this as a quadratic in x, keeping y as a constant, ax squared plus bx plus c equal to 0. If this is satisfied for some x value, that means this quadratic equation has a solution. This quadratic equation has a solution only if the discriminant b squared minus 4ac is more than or equal to 0. Oh, I'm sorry, more than or equal to 0. Right, correct? More than or equal to 0. Discriminant is positive or even equal to 0. Discriminant is more than or equal to 0. Discriminant is more than or equal to 0. Okay? Discriminant is more than or equal to 0. Well, are you getting this? A quadratic polynomial has real solution. Quadratic polynomial has a real solution if the discriminant b squared minus 4ac more than or equal to 0. Here I am looking that position. Ax squared plus bx plus c. Ax squared plus bx plus c. A is y, b is minus of 5x plus 1 and c is 6y. Discriminant b squared, look at b squared, b is minus of 5y plus 1, b squared minus 4ac, 4ac more than or equal to 0. Well, can you simplify this? On simplifying, this is minus of square will go plus 25y squared plus 10y plus 1 minus 24y squared more than or equal to 0, or that means y squared plus 10y plus 1 more than or equal to 0. I am inquiring into the possible values of y, where y squared plus 10y plus 1 more than or equal to 0. Can you tell me for what value of the variable a quadratic polynomial is equal to 0? Equal to 0 is getting when you solve that, whatever value of y you get will be equal to 0. At these two values of y, which two values? You know the solution by applying the quadratic formula. Y equal to minus 10 plus minus under root b squared minus 4ac, that is 100 minus 4 is 96, 16 6 are 96, root of 16 into 6 is 4 root 6, 2 cancels. For these two values of y, this quadratic polynomial is equal to 0. These two values, which two values? Minus 5 minus 2 root 6 and minus 5 plus 2 root 6. These two values, let me call it alpha and beta. For these two values of alpha and beta, this quadratic polynomial is equal to 0. Now, for what value of the values of y, quadratic polynomial is more than or equal to 0? That is the question. Can you tell me? Can you solve the quadratic inequation? Well, I have a quadratic inequation. I take the variable t, whatever variable you can take, x, y, q or anything. I'm only talking about the quadratic polynomial. A t squared plus bt plus c. If a is more than 0, this will be the quadratic equation. If a is less than 0, it is up and down. If a is more than 0, this is a quadratic polynomial. Yeah? When a is less than 0, it is up and down. Now, for which value of the variable t, ft is more than 0? More than 0 means it is above the x-axis. When is it above x-axis? When, if alpha and beta are the roots, when it is either when it is less than alpha, is above the root, above the x-axis, or when it is more than beta. Ft is more than or equal to 0 if t is less than or equal to alpha, or t more than alpha. Be careful about all these happens when the coefficient of quadratic term is positive. And when is ft less than 0? That is his portion. Less than 0 if t is between alpha and beta. T more than or equal to alpha, t less than or equal to beta, if t is less than alpha between t is between alpha and beta. This is a quadratic inequation. At squared plus bt plus c. When a is more than 0, it is open on. That value of the function, this is a function value, this is ft, this is t. Ft is more than 0 when t is either less than alpha or t is more than. Well, our polynomial was y squared plus 10y plus y squared plus 10y plus 1. We want it more than or equal to 0, and we have alpha, beta. Alpha is minus 5 minus 2 root 6, and beta is minus 5 plus 2 root 6. So this is more than or equal to 0 when it is less than alpha or more than beta. That is minus infinity to alpha union beta to infinity, or minus infinity to minus 5 minus 2 root 6, that is included, the open close, union closed open, minus 5 plus 2 root 6, that is beta, right? I'm referring to this less than or equal to alpha or more than or equal to beta. Your alpha is minus 5 minus 2 root 6, beta is minus 5 plus 2 root 6. Okay, both the values may be plus or negative, that is immaterial. I'm just taking a general case here. Okay, so that is the range of this. Well, your one question is here to show that this is a bijection, same one, no problem. But these two questions, be careful, try to do. Don't get, you can do it. I will do for you. This you have to answer me. Is it possible to construct a bijection from N to Z? If yes, you have to construct. If not, give me the reason. I will ask when we meet back Monday. Okay. Question 21 is again show that f from R to open interval minus 1 fx x by 1 plus support bijection. Well, 20 is done. You will do it. 21 you try. You don't do, then I will tell me. I'll do for you. 22 you report me what is the conclusion. All the best. Okay. We'll meet back